So in this presentation, we want to understand the flexion relaxation phenomenon. We can see that's what's being evaluated in this experiment. So we're going to use this as an example. The setup here is there's a person that has electrodes that have been placed along the erector spinae muscle in the lumbar region. And then we can see that they're also tracking motion with some sensors here on the pelvis and the lumbar. So first, though, let's talk about, before we start talking about muscle activity, the load on the muscles in this position. So here's a person that's been forward bending at the hips. So we could imagine their pelvis here, the hip joint here, leg, and then their spine is flexed like so. So the muscles, there's a moment then that's an external moment that's acting down to flex the lumbar spine, and we need some erector spinae activity to balance it. Otherwise the person would fall forward farther. So the model we can put there like this. So we have some of the center of body weights here somewhere acting down. We could calculate the moments here at L5, and that would give us a moment arm here. So we'd have trunk weight and times this moment arm. And so then we would have internally, we would have the erector spinae, potentially the multifidi muscles acting this way with their moment arm here. Okay, so we could do a simple equation here and say in this position, the external moment equals the internal moment. And so the external moment's TW, trunk weight, times the moment arm. And that equals the force in the erector spinae muscles times its moment arm. And so we can see, given the position, that the external load is fairly significant, and we would expect some muscle activation or force to be developed in the erector spinae or extensor muscles to maintain this position. So what we see, though, is something quite different. So this is the right and left erector spinae muscle activity here and here, and this is the tracing of motion from flexion back to extension. So essentially this is the person going into flexion here, this is them in flexion, and then this is them moving back into extension again. And what we can see is that when the person is in flexion, there's very little EMG activity in the erector spinae muscles. This is called the flexion relaxation phenomenon. So in other words, as the person moves forward into flexion, the muscles tend to turn off, even though they have this external load. So how do they balance the external load? So if we remember our force length curve, so this is length, okay, and this is force. It looks something like this for the contractile element. And this is the PE, okay. And together, they give a combined force like this. So the assumption here is that what's happening is, as the person flexes their spine, the lumbar muscles are lengthened beyond their resting length or their middle position for the CE, and then gradually as they lengthen this way, they recruit the PE. And so therefore they don't really need any muscle activation, but they can still develop the required force to balance the external load. That's the explanation of the flexion relaxation phenomenon. Now in this particular case, this is a low back pain patient, and we can see what's happened here. Here's the flexion point, and we can see that there's much more significant muscle activity, more even on one side than the other, during the flexion motion that they have. And so this would be abnormal, and so some people have sought to use abnormal EMG activation during a flexion movement to indicate chronic low back pain.